Hey, grade 10. Okay, so today is 20 AB, translation and rotation. It's quite fun. I love when geometry gets moving, so we can just like shift it around, right? So it's not just there for us to observe it. It moves, and I love that. So just an overview here. A few vocabulary words. We know what symmetrical means, so that means it's like a reflection, right? It's just remember whenever you were little, you paint. So you have a paper and then you fold it in two, and then you just paint one side, and then you cover the other side with that paint, and then you have a butterfly. Remember that? So that is a symmetry. And then transformation geometry. It means that we change figures by its size, shape, orientation, or position. So that's what we're gonna explore in the next week. So the original figure is called the object, and the new figure is called the image. So think of it as whenever you're taking pictures, you have an object to take a picture of, and then once you take that picture, it becomes an image, right? So before you do any transformations to a shape, it is called an object. But once you have translated it or rotated it, it becomes an image. Anything else that's not the original is an image. We'll consider the following transformations. We're gonna talk about translations, reflections, rotations, enlargements and reductions, and stretches. And I have Kim Kardashian's picture here. It's kind of creepy. I cannot tell which one is symmetrical. I think this one is the... Hold on. See, this is really creepy. I'm pretty sure this one is the object, the OG, and this is the image. So this is the before, and this is the after. And this is a really thick ink right here. Okay. So I thought that was interesting, just to wake you up a little bit. Here are some examples. Translation, it means to slide. So if you move an object to left or right, up or down, that's translation. We also have rotation. It means we rotate about O, or a point. So O is the origin, through angle theta. So it could be I want to rotate this triangle about the origin through a 90 degrees angle, or 180 degrees. It could be anything. And then reduction, pretty simple. It means just you're reducing an object. So if it were like twice that size, we're gonna reduce it by 1/2, and then we're gonna use K for the constant. How much are you reducing it by, right? Reflection, like Mulan, is just, again, just you have a mirror line, and then we're reflecting it over that mirror line. It could be over an x-axis. It could be over just a line. And then enlargement is the opposite of reduction. We're making it bigger. And then, last but not least, stretching. I think we have talked about this last year, invariant line. So we have this wall, right? So this is our, it's steady, it doesn't move. And then we're going to stretch it out. Okay? Think of it like you have the strings here. We're stretching it out. Stretching it to there, to here, here. Oh wait, no. The object is this, so this is the original. We could stretch it this way. Kind of smushing it, right? Then we could also stretch it that way. Make it even bigger. So yeah. Depends on your K. Could be 1/2, could be 2. Alright, so let's jump right into it. A translation moves an object from one place to another. Every point on the object moves the same distance in the same direction. So example 1, it says triangle OAB with vertices O, or the origin, and then A with the point 2, 3, and point B is -1, 2. It is translated, you guys might think that's weird. Isn't that the vector component? Well, we're gonna find out. So 3, 2 here is actually represented by HK. So this vector component here in transformations, this is how much you move. So this will tell you how much you move vertically, horizontally, oh, I cannot spell today, guys. Move horizontally, so left and right, because usually it's X, Y, right? Think of it that way. And then this one, how much you move vertically, up and down. Okay. Alright. Oh, I forgot to cover that up. So it says, this is our original here. This is our object. So O, A, B. Okay. That's our original, or our object. And we're going to translate it 3 units to the right. So 1, 2, 3. 2 units up. 1, 2. That's right. That's where O prime is. So that's what we call the little apostrophe. So that's just indicating that's an image, right? It is not the original anymore. So it's 0. It's O prime. Then we're doing that for B as well. 1, 2, and then 1, 2, 3. Doing that for A. 1, 2, 1, 2, 3. Okay. And yeah, and that's it. And then, as you may have noticed, if you write it out, as you can see, look at this. We're pretty much just adding the H. So remember, this is HK. The H is 3, and the K is 2. That's why we got O prime as 3, 2. Again, that's the same thing, 3, 2, because they're positive, 3, 2. So basically, when you're translating an object, you're just adding by H and K to each of the points. Easy peasy. Alright, so let's try it out. Example 2, it says, on a set of axes, draw the line with the equation y equals 1/2 x plus 1. Find the equation of the image when the line is translated through 3 and -1. Okay, so let me make this here. Okay. Alright. So I want you to remember that you need to label. In the IGCSE test, you need to label, okay? If they can't read your handwriting, they won't bother calling you. They'll just give you a 0, right? Okay. So let's label these, making sure what unit you go by. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Y-intercept is 1. Rise 1. 1, 2. And pretty much you only need 2 points, right? Because 2 points make a line. So that's what we're gonna do. Okay. It says translated through 3 and negative 1. So what I'm going to do, I'm going to label the points that I have. That's 0, 1, and then 2, 2. Okay, so I'm going to call this A and then B. If A is 0, 1, and B is 2, 2, and we're translating, so this is how you would write it. Translating through 3, negative 1. Okay, remember, what are we going to do? We're just going to add the h to the x and the k to the y. That's what I'm going to do. So A prime, in other words, my new A, the image, is 0 plus 3, which is 3. 1 plus negative 1 is 0. And B prime would be 3 plus 2. Wait, what do I have? Yeah, 3 plus 2 is 5. 2 plus negative 1 is 1. Let's plot that on the graph. 3, 0 is right here. So that is A prime. And we have 5, 1. B prime. And then just draw a line through it. If I could. Oh, this is harder than I thought. Okay, approximately that, right? There you go. So that's it. So find the equation of the image. Oh, okay, so we're not done. We need to know the equation. So that's easy. I would just go back to grade 9. I mean, don't go back, stay here. But I'm just gonna do slope intercept, right? So the slope would be y minus y1. 5 minus 3 is 1/5. Y equals to 1/5 x plus b. I'll pick 3, 0 to the 0. 3/5 plus b. B is negative 3/5. Okay, that looks right. So around that. So y equals negative, 3/5, 1/5 x minus 3/5. That is our image. Alright, I'm going to jump into rotation because I want you guys to go right ahead and do some practices. So rotation, when point P, which is xy, moves under a rotation about O, or the origin, through an angle of theta to any position P prime, the coordinates are x prime and y prime, then OP equals to OP prime. In other words, OP is equal to OP prime. Okay, so they don't, the distance is the same. That's what they're saying. So POP prime is theta, where positive theta is measured anti-clockwise because we're going this way. O is the only point which does not move the rotation. We'll concentrate on rotation 90 degrees, both clockwise is this way, and anti-clockwise or counterclockwise. And then we're just going to focus on 90 degrees and 180 degrees for now. Alright, so let's do it. So again, they will have a point that doesn't move, right? Because we're rotating about that point. In this case, origin. Okay. Alright, so let's jump in for example 3. So I left the answer there so you guys can see the image here. It says find the image of the point 3, 1. Let me highlight that, 3, 1. Under a rotation about O, or the origin, which is 90 degrees anti-clockwise. So they're saying So imagine it like this, you guys. So I have a pin here on the origin, and think of these dashed lines as a string, okay? So I'm holding point 31 here. So what I want to do is I want to go 90 degrees anti-clockwise. So what I'm going to do is I'm going to take this here and then make a 90-degree angle anti-clockwise. So right here. Okay? And I'll end up over here. So you might ask, Miss Stephanie, how am I supposed to know if I'm making a 90 degrees? Well, you have a protractor, right? So that's our first, what we're gonna do first. You're going to use your protractor, and then once you see that there is a pattern, you won't have to use the protractor every time. But I want you to know that where did all of these formulas come from? So simple. You use your protractor and just measure 90 degrees, right? There's nothing secret about that. You just use your protractor. Okay. Anyways, so once you get your 90 degrees, you will end up in -1, 3. This is your image. Okay. Alright. So now, let me erase all of this. How about we are going to rotate it clockwise 90 degrees. Again, start from the origin with your string, and then with you holding this point right here. So clockwise is this way. Again, use your protractor, 90 degrees. You'll end up here. Easy. Okay. Now they're saying do 180 degrees, but they're not saying clockwise or anti-clockwise. Why is that? I'll let you think. Why didn't they specify if it's a clockwise or anti-clockwise? Because it doesn't matter. Look at this. If I had my pin on the origin again, and I am holding the string here on 3-1, if I go 180, this is anti-clockwise, I will end up in -3, -1 here. But if I do it the other way, or clockwise, I also end up at -3, -1. So it doesn't matter. 180 degrees means just you're rotating half circle, right? There you go. So again, no secret about that. How do I know these are 90? This is 180. Use protractor. But I want you to notice this. Okay? Look at the pattern here. If we are rotating, so this is notes here. When rotating about the origin, and if you're rotating 90 degrees anti-clockwise, so for example, this is your object here. Your object is 3-1. Then your image, so let's say 3-1, I'm going to change it to XY. Then look at your image here. -1 is actually -y, and then 3 is X staying the same. Okay, I'm looking at patterns here. So again, for this one, XY, so it's 90 degrees clockwise, XY, and then this is Y, comma, negative X. Okay, and then for 180 degrees rotation, again, doesn't matter anti-clockwise or clockwise, it's pretty much you're just changing the signs, the opposite signs. And this is the pattern that we're going to use. Okay, so I want you to write this down, because you will not have your protractor all the time, right? So this is a little bit of a shortcut, all right, to make things faster. And we've seen that here, right? We're not just I'm not just giving you a shortcut of the blue, but we are looking at the observation. But note this, guys, if the center of rotation is not the origin, we'll need to find out. This is where we'll find this out. This is so fun. Okay, at least for me. Alright, so let's see. So what happens if the center of rotation is not the origin? What happens to our pattern here? Okay,